Assalamualaikum guys. I hope you all are doing well. In this video, we'll learn what is spectroscopy and various kinds of spectroscopy along with their application. So, without any delay, let's start the video. Okay, in this video we'll learn what is spectroscopy and why is it useful, methods of spectroscopy, infrared, visible, nuclear, magnetic resonance and mass spectroscopy. And beside that we will see the application of various spectroscopy. So let's start. Okay, first of all we need to understand why there is need for spectroscopy. First of all, we had to know the need for the spectroscopy. Uh, why do we need for the spectroscopy? Because millions of the compounds has been synthesized to date till now. So we have so many compounds, and each one have different bases of arrangement, right? And their bond position. For suppose we have a structure of benzene, and we have a structure of toluene, right? CH3. Let me change the color. Okay, so we have different kinds of compounds, and the all compounds have different structures. And why do they have different structure? Because they have different bond positions and they have different functional group. So in order to identify them, it's become essential to have the technique of spectroscopy. For to go in detail, I would like to break down the word spectroscopy into two sub words. One word we have spectro, another we have scopy. Like in microscope we have the word scopy, which means to see, examine. We use certain kind of spectrum, like we have infrared spectrum, we have visible light spectrum. So by using that particular spectrum we examine. Scopy means examine. 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 We examine. Okay, scopy means examine, and spectrum means by using a certain spectrum of light. When we examine compounds by using a particular spectrum of light, that is known as spectroscopy. In this slide we have learned what is spectroscopy and why do we need it. So let's move to another slide. As in the previous slide I have explained the definition of spectroscopy. um, if we can again go through it briefly. Spectroscopy is the study of interaction of electromagnetic radiation of light with the matter. Like in matter where we have any compound, in matter we have a compound, right? We have an atom. So when we study that arrangement of elements under the electromagnetic radiation, that is the different spectrum of light, when we study compound, that is known as spectroscopy. Now application of spectroscopy, if we look the general application of spectroscopy, so it has a wide scope of application in various fields of science and technology and significantly favored over conventional methods. We have other methods as well, but it is beneficial. It is easier and takes very little time to analyze simple. It takes very less time, like it does not take 1 day, or like you will say it and you will just analyze it. It's easier and take very little time, and it requires a very small amount of substances. Like we don't need to require a bulk of amount of substances or sample. We just need a simple amount of substances. It is the another second benefit or application. It provides more reliable information. Like first benefit, like it take a very little time, and second, we require a small amount of a substance of sample, and third is it gives reliable information about the structure. Some other applications of spectroscopy: it analyzes compounds, um, and analysis of water pollution, determination of protein structure, and analysis of forensic material. It helps in structural analysis. Like, for suppose we have a chemical compound in laboratory and we need to know, we need to identify it, so we can use this technique. And we can use in the quality of the drugs, we use this technique. And for water pollution, if we want to see certain chemical compounds, so we can use this technique. And we can determine the structure of protein, which kind of protein do we have in a sample. And forensic material, like if you take any sample from any blood sample or any sample, so you want to identify certain chemical compounds in that sample, so you can use the technique of spectroscopy. Now first we have infrared spectroscopy. Infrared spectroscopy is used to detect the type of bond and the functional group present in a molecule. Like in infrared spectroscopy, we look for the type of bond and the functional group. Two things: we see what kind of bond it has, like in a certain sample. If we look for a certain compound, so which bond that element has, or which functional group does it have. So we look for that in infrared spectroscopy. The atoms in a molecules already undergo vibration and rotation, we know. For suppose if we have, like, see, this is an atom, this is another atom. They vibrate, they are not still, they are not stagnant, so they vibrate, and their normal routine. However, when the molecule absorbs air radiation, like this molecule, if absorb this radiation, infrared radiation, it leads to increased intensity of vibration. If these elements, for suppose, absorb infrared radiation, so their vibration will increase, right? And this vibration is of two types, namely bond stretching and bond bending. Now, what we have learned, infrared spectroscopy will look for type of bond and functional group, like whether it has single bond, double bond, triple bond, or which kind of functional group does it have. Like, does it have aldehyde? Does it have alcohol? Does it have alkyl halide? Does it have ether? Does it have ester? So you look for that. And what happened? Each element undergo vibration, and when these elements absorb radiation, their vibration increases, and two phenomena occur: one, bond stretching, and another is bond bending. One is bond stretching, another is bond bending. We will look for that in detail in the next slide. Okay, what happened in bond stretching and bond um, bending? In bond stretching, the bond length either increases or decreases. If something is stretched, so either the bond between two elements, either it will increase or decrease, right? In bond bending, the bond angle between the atoms changes. What happens in bond stretching? Either the bond is in length is decrease or increase, while in bond bending, the atoms bond angle changes, right? So here are the region near infrared radiation, middle and far, that we observe this kind of range. Is just for a table for understanding. So one more time we revise this. In bond stretching, either the bond is increase or decrease, while in bond bending, the angle between the atom changes. Now you will more clearly understand the bond stretching and the bond bending phenomena in infrared radiation. You can see infrared spectroscopy. We have done, for suppose, this in infrared spectroscopy. So here you can see stretching. Here you can see stretching, here you can see stretching. This is symmetric stretching. For suppose if you break this, so equally it will divide it. Symmetry means if you cut something at a certain point, so it will divide into equal half. But if we cut here, so it will not divide it in equal half. If we cut like this from this point, it will not cut into half. This is stretching, like it become this. First it was here, now it leads to a little bit more. So here what happens, here happens bond increasement happen. Here bond is increased. Here another picture you can see a bending. Here we discuss the phenomena of stretching, in which bond either will decrease or increase. Here we see bond bending, where the angle changes. For suppose if this is three atoms, and this atom comes here, this atom comes here, so what happens, the bond angle will be changed here. I hope it is clear. So now we'll go to the next slide. So another we have ultraviolet visible spectroscopy. And what is it? Ultraviolet visible spectroscopy is used to determine the presence of double bond as well as conjugated system molecule. In previous slide, infrared radiation, we saw that it was used for looking for functional group and bonds. But in ultraviolet visible spectroscopy, we do not look for functional group. We just look for the presence of double bond or triple bond. What we look for, we look for double or triple bonds in ultraviolet visible spectroscopy. Now what happens in this, the UV region of the electromagnetic spectrum extend from 200 nanometer to 400 nanometer, and the visible region extend from 400 nanometer to 800 nanometer. We look for this phenomena for a particular compounds in a particular sample. And again visible light violet spectroscopy is used for just looking for the double or triple bond, not for functional group. And application of visible light spectroscopy and UV spectroscopy can provide visual information regarding the structure of a compound, particularly in relation to the presence of the double bond, triple bond, aromatic system, and heteroatoms. We look for the basically bond in visible light spectroscopy. And UV spectroscopy is extensively used for determining the concentration of unknown compounds in solution. Of course, we look for unknown concentration sample, whether it could be with using technique of infrared spectroscopy or visible spectroscopy. So particular for particular sample is Beer Lambert laws here apply. So we this is the topic for another subject. So here you can see below image where we have light source, and that light source in this image mechanism of visible spectroscopy is described. First of all, we have a light source, and then we have a monochromatic light, and then it passed through the sample. Like this is a light, and it passed to the monochromatic, and then it will pass to the sample in which we are looking for a certain compound, and it will go through a detector, and then we will detect that particular compound in a sample. Nuclear magnetic resonance spectroscopy. And what is it? The nucleus of certain elements like hydrogen proton exhibit a random spin and behave like a tiny magnet due to their charged nature. When an external magnetic field is applied, the spin of the nucleus align into ways. Like in the protons of a nucleus either move in clockwise direction or anti-clockwise direction. And when we applied magnetic field to that element, so what happens, two phenomena occur. One, either it can align in the same direction, either it can spin into the different direction. For suppose we have this, or so if we apply magnetic field, so it can align to that direction of the magnetic field, or either it will oppose the field of direction of the magnetic field. So this is what happened in nuclear magnetic resonance spectroscopy. Now, nuclear magnetic resonance spectroscopy, here you can see two images. One in which with no field, we have no field and they are spinning, and another with field. For suppose they are in the direction of, for suppose the direction of the field is in this direction, and they also spin in this direction. And if the direction of the field is this and they are spinning down, so they are spinning in opposite direction, as we have discussed this in previous slide. In this slide we are looking with images. Now, what is the applications of NMR? NMR spectroscopy is a powerful analytical technique. It provides valuable information about the chemical structure of organic compounds. Of course, we look for a chemical structure, right? What we look for? We look for a chemical structure of which compound? Organic compounds. Each organic compounds exhibit a unique NMR spectrum. Of course, every compound will have unique. So that's for, if they don't have unique structures, so we won't be able to identify. They will have unique absorption of a particular radiation, acting as a fingerprint that allows chemists to identify them. This technique is successfully applied in drug analysis. In this technique, usually we are applied in drug analysis and marital sciences, forensic analysis, and many other fields, particularly drugs and forensic science. Now we have another spectroscopy, kind of spectroscopy, that is mass spectroscopy. And what is mass spectroscopy? Mass spectroscopy is a technique used to determine the mass to charge ratio. Simply, to determine the mass to charge ratio, we look for the mass and charge ratio in a relation. So when we look for this, then that spectroscopy is known as mass spectroscopy. And the application of mass spectroscopy, it provides information about the mass of a different fragments. When we are looking for mass, of course we will identify the mass, so it gives information about the mass and play an important role in the structural elucidation of molecule. And no doubt, one thing is common in each spectroscopy, that it will elucidate about the structure of the compound. But some spectroscopy will determine the functional group particularly, and some will determine the double and triple bond particularly, and some will mass. And if you like forgetting, so you can rewind this video and you can see the previous slide as well. Now here you can see an image of mass spectroscopy. First of all, what happens is the mechanism is described in this image. First of all, ionization will occur of the certain compound, and then that will be accelerated, and then deflection will occur, and then they will pass through a electromagnet, and there will be a vacuum pump, okay, where we will remove excessive air or other things, so that contaminate, to avoid contamination. And then we will have a reductor through where we'll deduct this, and to amplify this we will have amplifier, and then finally we will have a chart. Hope this video was useful and you enjoy watching this. If you like, so do subscribe. Thanks for watching.